Okay, today I've handed a worksheet out to you, and it's on Aufbau's diagram. Aufbau, excuse me, Aufbau um, came up with a diagram that we can use and it's this. It basically shows all the orbitals and the energy levels in a certain order. It also uses the diagonal rule, which I've also placed on here to show you that how it follows it. Let me get out a couple of little markers here. Let me show you how we followed Aufbau's diagram. Right over here, we've got the 1s. And on the diagonal rule, our first place we go is the 1s. And as we go up the diagram, it shows you the next energy level, which is a 2s. And sure enough, on the diagonal rule, 2s. Diagonal rule next we use is 2p. Here's my 2p. 3s is next on Aufbau's diagram. Here's my 3s. We follow the diagonal rule. 3p is the next energy level. Sure enough, 3p is written as we go up the diagram. 4s is the next energy level, and here's my 4s. Then I go to my 3d, my 4p, my 5s. Then the next one I go to on diagonal rule is 4d. Sure enough, the next one up the diagram is a 4d, then the 5p, then the 6s. Then I go to my 4f, 5d, 6p, 7s. Okay, so that's how we use the diagram to help us. It's simply another way of helping us put electrons onto the energy level, energy levels. Excuse me. Now, as you notice, there's little boxes here. The little boxes represent the orbitals. Now, the orbitals are simply the little slashes that we had whenever we did it a couple of days ago in your notes. So, as you notice, on the 1s, there's one orbital. On the s, there's one orbital. On the p, there are 3 orbitals. On the d's, there are 1, 2, 3, 4, 5 orbitals. And on the f, there are 7 orbitals. All right, now let's look at a couple of these principles right here. Aufbau's principle says that the electrons enter orbitals of the lowest energy first. So the lowest energy is down here on the 1s. Then it goes up to the 2s, the 2p, the 3s, and it just goes up the diagram. Same way as the diagonal rule. Is just a different way of looking at it. There's another principle called Pauli's exclusion principle, which says an atomic orbital contains a maximum of 2 electrons. So each one of these orbitals can have 2 electrons. Remember, one going up and one going down. All right, here we've got 3, so each one of these can contain up to 2 electrons. That's Pauli's exclusion principle. And then the last rule is called Hund's rule. It says when electrons occupy orbitals of equal energy, 1 electron enters each orbital until all the orbitals contain 1 electron with spins para, which means spin in the same direction. So in other words, we put 1 up here, there's no place else to go, so we put 1 down. Right here, the 2s, we put 1 up and then 1 down. On the 2p, since there are 3 orbitals, we put all the spins first. So we'll go up, 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 and then back down to the beginning. Down, down, down. On the 3s is 1 up, then 1 down. On the p, once again, is 1 up, 1 up, 1 up, then 1 down, 1 down, 1 down. 4s, 1 up, 1 down. 3d, 1 up, 1 up, 1 up, 1 up, 1 up. Then 1 down, 1 down, 1 down, 1 down, 1 down. That's how they enter. These are using the principles listed down here. Now let's take a look at one real quick because you're going to do some electron configurations. So I want to make sure you know how to use this. Let's go ahead and do potassium K. I'm just going to fill it. I'm going to put it right up here. Take a look real quick. Make sure you're still recording. I'm just going to put it right here. Potassium is the letter K. potassium has 19 electrons. 19 electrons. All right. So I need to fill these in. So I start at the lowest level and I put one up. Oh, let me get a pencil that works. I'll put one up, one down. That's 2. Then I go to my 2s. If I follow the diagonal, it's 2s. Put one up, one down. That's a total of 4. Then here I'm going to put one up, one up, one up, one down, one down, one down. So now I have 2, 4, 6, 8, 10. I need 9 more. So in the 3s, I'm going to put one up and one down. Remember, these are electrons. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, and I need one more, so I'll put it right here on the 4s. Okay, now I have my electrons or energy arrows in my orbitals, so I simply look and see how many there are of each. On my 1s, I have 2 electrons. On my 2s, I have 2 electrons. On my 2p, I have 2, 4, 6 electrons. On my 3s, I have 2 electrons. On my 3p, I have 2, 4, 6 electrons. And my 4s, I have 1 electron. Only one. Now, this is called the electron configuration for potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And I used my 3 principles. Aufbau's principle, which simply states that it goes to the lowest energy first, right here, energy level, and right here. Pauli's exclusion principle says I can have 2 electrons on each orbital. Sure enough, I have a maximum of 2. And then Hund's rule that says the ups go first, then the downs. All right? Okay, now go ahead and turn it over. Go ahead and turn your paper over. And on the other side, you have, let's see, where is it at? You have your electron configuration practice worksheet. I want you to go ahead and give me the electron configurations for each one of these elements, okay? Look up. All you got to do is look up, see what the atomic number is. A good example is sodium. Sodium is Na. It has 11. It has 11 protons. Therefore, it has 11 electrons. So I need to place 11 electrons onto my diagram or using my diagonal rule and find out what the electron configuration is. And just write it right here and do them for the rest of the period and you'll be done. All right. That's all for today.